so that it doesn't appear on record as fibers, and then you end up seeing it was presented that way. So this is nerve classifications, and if you can, who can remind me the difference between the nerves and the nerve fibers? Quickly, you did that in class. What's the difference between a nerve and a nerve fiber? Yes, Cecilia?
A nerve is the functional cell, which is a neuron, sorry.
Yes, continue.
And the nerve is a bundle of axons.
Okay. Nicholas?
That's the same thing I wanted to say.
Okay. So when you talk of a nerve fiber, you're actually talking of a neuron. And a neuron is the functional unit of the nervous system. Then the nerve itself is the one which is a bundle of axons, and it is made up of numerous nerve fibers. So we classified them. I think both classes were able to look at all these classifications that I have placed in this slide. So I can skip this slide and move to the next one. I will mute you all so that you don't have a lot of background noise. If you want to talk, you unmute yourself. So now, today I wanted us to talk about where some of these nerve endings are, which are the sensory nerves, where are they coming from. Because I realized we have not talked about receptors, and I'm mentioning some of these receptors. So I've just organized two or three additional slides to show you the location and what are these receptors that we are talking about. So I saw this slide which is capturing most of the information that I want to give you. If you look at the nervous system, one of the way we classify the nervous system, or the sections of the nervous system, is that you have the afferent fibers, which are bringing information to the CNS, and therefore they are the sensory ones. And then we have the other class, which are the efferent fibers, which are taking information away from the CNS. Now, if we forget about the motor fiber and focus only on the sensory fibers, these are coming from specific areas. One of them are the special senses. So when somebody tells you to use your common sense, they are talking about your eyes, your ears, your nose, your tongue, because those are senses that are common to everybody. Yeah? So those are the special senses. And then, in addition to this, we have other sensations that are from all over the body. You cannot specify an individual organ. Now, with the special senses, you can see that the receptors, the nerves or the neurons which are bringing in information, are clustered in a special organ. And if you remember our classification of organs, what they are. Yeah, so there is the organ for vision, which is the eye. There is the organ for hearing, which is the ear. And that one for smell, which is the nose, and the tongue for taste. Those are special organs, and they have special receptors. Now, the other receptors are able to detect sensations from all over the body. They are not specifically organized in one area. So, for instance, if I talk about touch, if I came to the back of your neck and I touched you, you'd feel that sensation. If I come to your arm, I touch you, you'll feel the sensation. If I touch your face, you'll feel the sensation. Now, these are made up, you're feeling the sensation from receptors, which are specially designed to detect touch. However, they are not organized in one special area. They are distributed all over the body. Similarly, when you have proprioceptors, or these are the ones which detect movement, they are usually found within skeletal muscles or within the tendons. So even those ones, if you look at the skeletal muscles, they are distributed all over the body. Tendons are distributed all over the body. So even these ones are diffuse, they are distributed everywhere. And so are the pain temperature receptors. Now, having known the somatic senses, these are what we call the somatosensory receptors. I wanted to enlarge the proprioceptors. Remember, we talked about those ones which detect movement, and these are embedded either in the skeletal muscles or in the tendons. So I have enlarged these ones, this being part of a muscle. So you can assume that there is a bone here at this end, and there is another bone here at this end. And in between are muscle fibers that are comprise the muscles that you know. So these are the skeletal muscles, and they aid in the movement of these bones. Attached to the muscle fibers or the muscle cells are the tendons. These are connective tissues. If I were to enlarge part of this tendon, I will get inside, embedded in the tendon, are these nerve endings. And these nerve endings are able to detect when you stretch the tendon. So for instance, if I were to contract this muscle, I will pull against the bone. And when I do that, I will stretch the tendon. When I stretch the tendon, I will also stretch these nerve endings, and they'll give me some sensation. Now, similarly, embedded in the skeletal muscles, we have the stretch receptors, which will detect the stretch of the muscle. So when I straighten, if this is an arm or the leg, if I pull against this or these two bones apart, it will stretch the skeletal muscles. So you can imagine if you have your biceps and you stretch out your arm, you're going to stretch the biceps. When you do that, what you'll find is that embedded in the skeletal muscles are the muscle spindles. So when you stretch the fiber, you also stretch the spindle. Now, I equate this. I'll use something which is not very nice to utilize, but you can think of it. It's a nice analogy, but some people may think it is disgusting. You know that some people have hair, and hair is nothing but long fibers. Okay? Now, what I say you might find disgusting, you can imagine if I took this hair fiber or strands of hair. I don't know how many of you are familiar with lice. Okay? So if I were to use these dark circles here, you find that these lice tend to get stuck to your hair. So they are distributed all over the muscle, the hairs. So you can imagine if this hair is stretchable and I were to bundle it end to end, and then I pull, you find that even the lice that is stuck there will be stretched as you stretch this hair. So these small tiny things are representative of the muscle spindle receptors, whereas this long fiber is representative of the skeletal muscle. So when you stretch it, you also stretch all these things that are embedded within the muscle fiber. So I wanted to show you these slides for the purpose of knowing that we have different sensory neurons coming from these fibers. We have some sensation that is going straight to the skeletal muscle. This is a motor neuron. Motor means that it is bringing information from the CNS. I really don't know how to write with this thing. It is taking information from the CNS and it is taking it to the muscles and causing the muscles to contract. So it is a motor neuron. And you can see the classification, it's an alpha. We'll come to that later. Then we have another motor neuron that is bringing information straight to these muscle spindles, because if you enlarge one of the muscle spindles, this is the structure you get. So there are those neurons that will take information to the spindle. They are also motor neurons, but now they are of the gamma type, and we'll come to see what gamma is. So I wanted you to note those ones that are bringing information. So some are taking information into the muscle spindle, but then there are those ones that are taking information to the skeletal muscle. For the class that I had explained, I said that you need to have both of them contracting at the same time so that you don't have the skeletal muscles contracting and then they leave the spindle stretched out. So you have to send information at the same time to the skeletal muscle and to the muscle spindle so that they contract concurrently at the same time. Now, we said that this spindle is a stretch receptor. It means that when you stretch this muscle, you also stretch the muscle fibers within the spindle. When you stretch them, you can see that there are some other neurons with nerve endings surrounding those muscles. So when you stretch the fibers, you also stretch this, and this will take information away towards the CNS. So for this reason, these are afferent or sensory neurons. And as you can see, we talk of type 1A and type 2. Again, you'll understand this when I go to the classifying the types. So what I needed you to note, when it comes to these sensations, we have a 1B here, which is different from the 1A here, which is different from the type 2, which is different from the gamma, and which is different from the alpha. And all these are neurons innervating the muscles and the Golgi tendon organs. Are we together on this part?
Yes.
Yes.
Anybody
Yes.
who is lost before I move on? Because when I start classifying, I'll just be referring to the gamma motor neuron or I refer to the alpha motor neuron. But you need to know that they innervate different parts and they also get sensation from different parts of the body. Okay, so if you are okay with that one is only capturing the proprioceptors. So I want to go to the next one, which is capturing the cutaneous receptors. These are the ones which are found on the skin. Remember I talked about touch. If I touch a part of your body, I'm going to stimulate one of these receptors. If I prick you and you feel pain, I'll stimulate one of these receptors. If I come and vibrate something on your skin, say for example, when you feel the phone vibrating, you are stimulating one of these receptors. Okay. When you feel temperature, cold or warm, you are stimulating one of these receptors. All these are found within the skin. So we call them the cutaneous receptors. So if I were to take you back to this slide, you can now see what I meant. We have the special senses and then we have the general senses. The general senses, we have the proprioceptors, which we have classified into the Golgi tendon organ and the muscle spindle. Then we have these other cutaneous receptors coming from the skin for touch, for pain, for temperature. Okay, and even vibration. They have listed the vibration here. So all those are cutaneous receptors. So with that information, I can go now to start classifying again. For I think it was group Y, we had already covered this, so it will be revision for you. For group Z, I had not reached that point. So we have two methods of classifying nerves. We use the Langerhans classification, and then there is also the Lloyd's classification. Now, I want you to note that in the Langerhans, number one, it uses the ABC system. That means it is using letters. I hope you are writing this down, because I always tell you, even in the online, you should be having something to note. You can see I have not written that here, but I will let you know that the Langerhans uses the ABC system. The Lloyd system uses Roman numerals. So type 1, type 2, type 3 written in Roman numerals. Number two, you find that the Langerhans captures classification of both motor and sensory neuron. The Lloyd's classification only captures the sensory sensations. The third difference, Langerhans has three major classifications, that is ABC. The Lloyd's classification has 5 types, is it 5 or 4? We have type 1, type 2, type 3, type 4, and type 5. So, let me just classify, type 4 fibers, sorry. They go up to type 4, not type 5. So, we'll see that. So, let us look at the Langerhans first. So we say that you have type A, B, C. Now A, B, and C represents neurons, and you find that the largest ones are the A bundles. The A fibers consist of the largest size of fibers, okay? When it comes to the B fibers, they are intermediate in size or diameter. The C fibers have the smallest diameter. Okay, so we have A, B, and C. So if we look at these A and B, this has myelinated fibers, while the C do not have myelinated fibers. So if you look at the speed of conduction, if you look at the A fibers, they have the largest diameter and they have myelination. For that reason, they are very, very fast. On the other hand, the C fiber, just hold on. Okay, sorry about that. So I was talking about the speed of conduction you find that the type A are the fastest, the type C will be the slowest. Type A are the largest in diameter, C will be the smallest. AB myelinated, C are not myelinated. So if we look at type A, it is further classified into A alpha, A beta, A gamma, and A delta. So A alpha are even larger than all the other beta, gamma, and delta subclassifications of A. A alpha is the one that is responsible for innervating skeletal muscles, for the simple reason that we want the highest speed to be taken to the skeletal muscle to help you in balance. You don't want to send an impulse to your muscles, and by the time they are contracting to maintain your balance, you're already on the ground, you are falling. So they need to be very, very fast. So let us look at the three classes. We have type A, type B, and type C. So if we focus on A and we look at the sub-classifications, remember the Elanga-Gaisa, we said it has both motor and sensory neurons. Skeletal muscles, they are innervated by the A alpha. So are they motor or sensory neurons? Skeletal muscles, A alpha. Is that sensory or motor?
Motor.
I had only one person say motor.
Yeah.
How many think it is sensory? So if from my, yes? Someone was talking? You can unmute yourself if you want to say something. But motor, if the answer is actually on the screen. They are efferent fibers. So they are motor neurons. They cause an effect, and the effect is contraction of the skeletal muscles. So the A alpha are actually motor. Now remember, from the skeletal muscles, we have the muscle spindles. And the muscle spindles have some afferent neurons. And some of these afferent neurons are also under that classification, and therefore they are sensory. We also have the Golgi tendon organs also having some of these sensory neurons. Now, to avoid confusion, you find that the skeletal muscles are actually referred to, the innervation is referred to the type 1A neurons. But then when you come to this other one, you start talking of the type 2 and 1A and 1 beta. And I'll show you what I mean when I go back to the spindle. So what I wanted you to note is that we have both afferents coming from the muscle spindle, afferents coming from the Golgi tendon organ, and they are of the A alpha type, according to the Elanga-Gaisa classification. In addition, we have those neurons which innervate the muscle spindles, and we call this the A gamma. So they innervate the muscle spindle. If you remember, that spindle had some muscle fibers here, and towards this end, you could see some fibers. Towards the end of the bundles, these bundles, there were some fibers. Those are the gamma, because when you contract using the alpha, when you contract the skeletal muscle here, you also want to contract these muscle fibers inside the spindle. So when you innervate when you stimulate the alpha motor neurons, you also stimulate the gamma neuron so that they all contract at the same time. When it comes to the afferent neurons, remember, again, these ones were found within the spindle, and you look at the muscle bundles, we had the afferent neurons here. And these are the ones which are giving the sensation. Okay? So when you stretch the spindle, you also stretch this part, and this sends information towards the CNS. So they are sensory neurons. So the other class of type A fibers are the B or the beta. These are responsible, they are cutaneous receptors. They are the ones which are responsible for the vibrations. So when your phone is vibrating, the A beta fibers are the ones that are stimulated. When you touch your skin, they are the ones that are stimulated. When you flutter or you just place a piece of paper and you simply move it very lightly, then those are the ones that are stimulated. And all this you're going to encounter when you go to the lab, when you're doing receptor physiology. I have already mentioned about the gamma, type A gamma. They are motor neurons, but they serve the muscle spindles. Now, the alpha delta moves away from touch, moves away from the skeletal component, but captures another sensation, which is cold and pain. Now, the pain comes in two components or two aspects. It can be the immediate sharp pain that you feel when you step on a sharp object. Immediately you feel it and you react to it. But then there is also the dull pain that comes later. And that one is captured by a different type of fiber. So the dull pain, remember, dull usually comes slow. Slow are non-myelinated C fibers. So the sharp pain is very fast, and because it is very, very fast, you have myelination. So the type A delta, they are myelinated and they are large fibers. Now, in between, we have the type B fibers. These are usually myelinated, but they are smaller than the type A fibers. These are the preganglionic fibers. Now, for those people, again, the group that I discussed in class, I showed you the positioning of these fibers. So this is a ganglion. Let me see if I have another one. No, I don't. So I can draw for you. If you want to draw, I can use this part to show you some of these fibers. If it is a motor neuron, it is coming from the brain, and at times it usually leaves through the dorsal root. So it may have the cell body within the dorsal root here, or it may have the cell body up there. Now what happens is that from the cell body, you have the axons coming out. And when they come out, they may reach a point whereby they synapse with other neurons. And when you find they are synapsing, there usually has an aggregation of cell bodies making a ganglion. This aggregation of cell body is usually located outside the CNS. So it is a ganglion. So these fibers, will come and terminate before the ganglion. And then we have those neurons that will start from the ganglion and they go to the effector organ. Remember, these are motor neurons, so they are taking sensation from the CNS to the effector. Therefore, fibers that are appearing before the ganglion are the preganglionic fibers. These fibers comprise the type B. Remember Ehrlinger-Geiser system, ABC. The preganglionic fibers represent the B fibers. For that reason, are they motor or sensory?
Motor.
Preganglionic fibers, are they sensory or efferent?
Efferent.
Lucy Wainaina, are you in class?
Yes, I'm in class.
Are they efferent or sensory?
Afferent.
They are efferent, so they are motor neurons. So, if you remember, at the beginning I gave you differences between the Lloyd's and the Ehrlinger-Geiser classification. So what do you think? Will they appear in both classifications?
No.
Yes, Samuel.
No.
Why? In
Because
which
you have,
classification won't they appear?
they will appear in Ehrlinger-Geiser classification.
Only. Why?
Because you said Ehrlinger-Geiser classification deals with sensory and motor sensations, nerves.
And the
But,
Lloyd's.
but the other classification deals with sensory sensations.
It
nerves.
deals with only sensory neurons. So I hope Winnie, are you there?
Yes, I'm here.
I hope you captured that.
Yes.
Sensory neurons are classified only by the Lloyd system. So in that case, we are not going to have this classification because in the Lloyd's, because these are motor neurons. Now, so we have talked about type A. Some of these cells are type A here. They are cutaneous receptors, pain, and all that. Then the muscle spindles and the Golgi tendon organs are also type A. So type B are preganglionic. It leaves a type C, which are usually the postganglionic. So preganglionic B and postganglionic will be type C. Number 2, type C, in addition to having the postganglionic, is going to have the temperature receptors or thermoreceptors, which will capture both hot and cold sensation. So temperature, cold, and hot, or you can call it warm. Both of them will fall in the C category. Number 3, we also have the dull pain. The slow pain is also captured in type C. Okay, so we have postganglionic, and then receptors will be temperature, cold and warm, plus pain, the dull pain. Sharp pain, remember, it falls under A delta. It is very fast, but it is slower than the cutaneous, and it is slower than the proprioceptors. Vibration, touch, all those, they also fall under cutaneous, but slower than the muscle spindle, so they are usually the beta. Muscle spindles, skeletal muscles are very, very fast, so they are the alpha, which leaves the A gamma, which falls under what? Who can remind me? Gamma. Where do you find them?
Inside the muscle fiber. Inside.
Inside the muscle fiber. Where specifically? In the
muscle spinal.
In the spindle, yes. So these ones and these ones will be found in the spindle. Beta are cutaneous, and these ones are the slower, but slower than the other receptors, but the sharp pain. So if you capture all that, you'll be able to remember the the Langer-Geisser classification. So if you're okay with that, let's classify using, here they are. So it is, I usually try to use pictures so that you can remember, but you can see I've talked of the A alpha, A beta for the cutaneous receptors, gamma for the muscle spindle, and delta, cold and sharp pain. Now, temperature, warm and cold, plus the dull pain comes in type C fiber, which also includes postganglionic. The preganglionic are the type B fibers. So initially it looks very complicated, but if you divide it like that and you remember what receptors we are talking about, then you'll be able to remember, or you can easily recall. So let us look at the Lloyd's classification. I don't know why, I've never understood why they put double L, because even if you put one L, it is still Lloyd. If you put double L, I don't know, I can pronounce it Lloyd. I don't know. Anyway, let's look at what this one looks at. Like I mentioned, it only focuses on the sensory fibers, which puts me to a point of correction. I said that this is classifying nerves. Actually, it is classifying fibers, because at the end of the day, we are taking a single neuron from a single sensation and taking it to the spinal cord. So that is not a fiber, it is that is not a nerve, it is a fiber. So it is a single cell. So my original title was actually right. They are fibers, not nerves. So just a point of correction there. So let us look at type 1 fibers. So according to Lloyd, number one, what he looked at is the kind of sensation that these fibers are detecting. Number two, he looked at the diameter of the fibers. And number three, he checked whether they are myelinated or non-myelinated, and he classified them according to that. So he looked at three components: their origin, because they are sensory fibers. All of them are sensory fibers, but which sensation are they coming from? Number two, what's the size of their diameter? And number three, are they myelinated or non-myelinated? So with that information, you can see that type 1 fibers only captures sensations from the muscles and the Golgi tendons. So these are proprioceptors. We have sensory neurons coming from the muscles, the stretch receptors, having type 1A, because type 1 is both A and B, with A only focusing on the spindles and type 1B focusing on the Golgi tendon organs. So it makes it easier than the other one, because the other one will have the A alpha, A gamma and all that. But this one has type 1A and 1B. Is it coming from the spindle or is it coming from the Golgi tendon organ? Then number 2, he looked at type 2 fibers. And these ones comprised the cutaneous nerves. But you find that even with these, we still have the type 2 fibers because of their size and myelination. So they fall under this category, but they also happen to come from the muscle spindles. Now, number 3, again, we have some of the pain we are talking about and the cold. So these ones are equivalent, as you saw from the Elanga-Gazer, they'll be equivalent to the which class? According to the Elanga-Gazer, cold and sharp pain. Cold and sharp pain. Which class according to Elanga-Gazer? Anyim, Alice.
It's the alpha delta.
Alpha delta. So you can see that they sort of overlap. Now, if you look at the cutaneous ones, they were under which classification? Cutaneous, the ones that are coming from the touch, vibration, and all those things.
Alpha beta.
Alpha beta. So we are going to actually align them in parallel so that we see type 1 fiber according to Lloyd is what classification according to Elanga-Gazer. But you see there is that overlap. Now, because we do not have motor neurons, we cannot have the equivalent of type B. So we move from type A, which is represented by type 1, 2, and 3, and then we move to type 4, which is equivalent to the type C fibers. Again, if you look at the sensation, it's coming from pain and temperature and crude touch. Okay, so let us look at what you have in your textbooks, because I got these diagrams from the textbooks. Oh, first I did this aligning so that you can see what is the equivalence. So type 1 fibers are equivalent to the A fibers, A alpha. Type B are the A delta. Type 2, sorry, are the A delta. Type 3 are, oh dear, my tongue is sleeping. Type 2 are the A beta and type 3 are the A delta. So the type 4 are the C fibers, we don't have equivalent of B. So if you go to your textbook of medical physiology and Ganong, you're going to find tables. I think this one is from Ganong. If you see the chapter is small, it is representative of Ganong. When the chapters are in the double digits, it's usually from textbook of medical physiology. So we have the fiber type here from A, alpha, beta, gamma, delta, the type B, and the C. Dorsal root means they are there. They are sensory. Oh, sorry. Okay. So if they are from the dorsal root or they are appearing, joining the CS via the dorsal root, it means they are sensory receptors. So these are the pain and temperature. But you can have C fibers, but they are exiting this spinal cord via the ventral root, and those are the postganglionic fibers. Okay. Lydia. Oops. Thank you. Okay, sorry about that. So I wanted to, there's another table actually. Yeah. Now in this table, it actually compares the Lloyd system. This is the Lloyd system on your left, and it compares it to the Elanga-Gazer on the right. So as long as you are able to follow what I was telling you, you'll find that it will be very easy for you to look at this and relate to them. But I always insist, for those people who love memorizing, you can dismiss what I told you and just come and memorize this table. The problem is when you memorize and you don't understand why you have one A and one A alpha, you won't know the difference between one A and A beta. You'll just mix them up. Most likely, you will not be able to recall in an exam setting. So kindly remember, speed. You need speed for the skeletal muscles. And this will be both captured in the spindle and the skeletal muscle fiber itself. And this is usually captured by the A alpha, but we also have the A gamma motor neuron, which also innervates the muscles. So I think I'll move from there so that I can capture more information. Let's see. So this table again, this one I got it from textbook of medical physiology. As I told you, if you see a small numbered chapter, single digit or a lower level number, it is usually from Ganong. And if you see a high number, it's usually from textbook of medical physiology, the TMP. So this image, I captured it from TMP, and it is showing you the same thing I had mentioned. It's looking at myelination versus non-myelination. Number two, it is looking at the fiber diameter, and you can see the largest fibers that are myelinated fall into the alpha category, A alpha category. And then as you decrease the diameter, you go to the beta category. As you increase further, you go to the gamma category. And as you increase further, you have the delta category. All these are the A fibers. Then you move to the B fibers, which have not been indicated here. And then you go to the C fibers, which are not myelinated. But you can see that the C category also have a range from 2 to 0.5 micrometer diameter. So they are very tiny. Remember, a micrometer is like a millimeter divided by 1,000. So you can imagine the size of an axon. So when we are talking, if you cut through the axon, it can be 0.5 of a micrometer. So if you take 1 millimeter, divide it by 1,000, and then you get 1 micrometer, and then you divide by half, that will be the diameter of the smallest fiber. So you cannot see that with your naked eye. But you find that they'll start increasing, but they are still less than 10 in the non-myelinated ones. However, when you start looking at the myelinated fibers, they can go up to 120, which is also just about 0.1 of a millimeter, which is very big. So I think from that you can look at this table, looking at the Elangagesa classification in the upper level. Then we have the Lloyd's classification in this lower level, also indicating the diameters of the fibers. You can see the diameters of the fibers with type 1A and B being the largest. Then we have type 2, and we have type 3 and type 4. Any questions so far? Any question? Now, this is looking at some of the characteristics of the muscle fibers. Apart from what we looked at, the diameter, the size, the speed of conduction, there are also some responses of these fibers that differ depending on the classification of the fiber. Now, you find that let me first block this so that we can focus on some of the things that are usually will affect the speed of conduction. So if you expose nerves or neurons to hypoxic condition, hypoxia means low oxygen supply. That means they are kept without enough oxygen. If you expose them to that, you find that you are going to slow down their speed of conduction. You're going to affect their functionality. And this could explain why when you apply pressure to a part of your limb and you apply so much such that you occlude, you block the blood vessels. Remember, the blood vessels are the ones supplying blood, and the blood is the one which has oxygen. So if you block, it means that that area will not have fresh oxygen supply. So you are exposing the area to hypoxia. And in that case, you will not feel the sensation, or it will be slowed down. Number 2, pressure. I have just mentioned that if you apply pressure in a certain area, even before the hypoxia has set in, that pressure on its own is enough to slow down or to block conduction of an impulse. Number 3, local anesthetics. You can apply something locally, and once it is absorbed, in fact, most of the cases, when you have these, they are organic substances. So they dissolve and they pass easily through the skin. Now, when they reach where the neurons are, if you remember, when we're looking at the structure of the composition of the myelin sheath, we said that the myelin sheath usually has phospholipids. And because it has phospholipids, it is lipid soluble. So substances that will easily dissolve in solvents can penetrate that myelin sheath very easily, and they can cause damage to that neuron. So you find that some of these anesthetics, they'll go and penetrate and reach the nerve. And when they reach the nerve, they are going to numb the nerve so you don't have any sensation. Now, the response to all these noxious stimulation, noxious, it is something that is not good for you. So hypoxia is not good for the nerve, pressure is not good, the anesthetics are not good. But their response by the individual fibers will depend on which fiber we are talking about. So if you look at hypoxia, the B fibers are the most susceptible, whereas the C fibers are the least susceptible. Okay? When it comes to, sorry, it is the other way around. B fibers and C fibers least susceptible. So if you look at this sensation here, hypoxia, we have B. That means you just need a little deficiency of oxygen, and you see the B fibers are the ones who will lose action functionality. On the other hand, the least susceptible are the ones for C fibers. This is the dull pain. Okay, it's not sharp. You can feel it, Crude touch, you can feel it. Yeah. And what else? What was falling in the category of C fibers? Non-myelinated, post-ganglionic. Which ones are they? I will just, okay, then you move to the next one. I'll ask you to go back and check A, B, and C fibers. Now, when it comes to pressure, on the other hand, always remember, if you lie down in one position and you apply too much pressure in a section of your limb, most of the sensations that you don't feel are related to movement because of the muscle spindles. They are related to touch at that area. But you find that you still be feeling things like pain. So the most susceptible will be the A fibers, the least susceptible are the C fibers. Okay. You still have that dull pain. The sharp pain is usually not there. Okay. Now, local anesthetics. Again, it is opposite of what you find in pressure. The most susceptible will be the C fibers, those that are focusing on pain. So once you are given an anesthetic, you can stop feeling the pain, but you can still feel the touch. And I'll tell you, like, if you visited a dentist and they numb you, you actually don't feel the pain, but you can feel everything the dentist is doing in your mouth. So you are getting rid of the pain, but you still have the other two sensations. So I think this is the last slide, if I'm not sure. Let me see. Yes, I knew that was the last slide. So I want to ask if you have any question on those classifications, because I will not go back to them, but I will question you and you'll encounter them during your receptor practical on receptors. Questions? Angela Mureithi, tell
Yes,
me
Prof.
something.
Okay, I actually don't have a question for now. Yeah.
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 But you have a comment? You have a take-home message?
I just want to say thank you for what you're doing for us, for helping us to understand and for caring about how we process this information. So yeah.
Thanks for that. It's a compliment, but I also want to know, did you take home any message?
Yes, although it's definitely something to review again to make sure
Pardon?
I'm saying yes, it's something that I've learned, but it's also something that needs to be reviewed again to make sure
You
that
must have got, even without reviewing, you must have understood one thing, just one thing.
Okay. So basically there are two different classifications of nerves, the nerve fibers, and those two different classifications are, there's the Geyser one and then there's the Lloyd, and they are kind of like complementary, where in some of the classifications for Geyser we see similarities with the ones for Lloyd.
Okay.
Yeah.
Alamin, can you add on to what Angela has said? She has said there are two different types of classification. How can you distinguish the two? Just one difference. Alamin. Alamin, I want to give people a break and you are holding us back.
Prof.
Yes?
Yeah, I was saying
Yes, go ahead.
Or it can be classified according to either their locations or where they originate or their conscious input.
Okay, conscious input. But I wanted you to, did you capture one of the differences between the Lloyd system and the Alanga-Geisa? Just one. I gave, I think, 3. So just give me one difference that you find in one or not the other. Go ahead, Alamin. I'm waiting.
Madam, that one I'll have to review it back.
Sebata, tell him.
So the Elangesa uses the ABC system, and then the Lloyd system uses the Roman numeral 1, 2.
Alamin, can you write that down? I'll ask you at the end of the lecture. That is one
Okay.
difference. Another difference, somebody else. Another difference?
Yes, Prof.
Yes.
Master.
Go ahead, Aiden.
Yeah, Elangesa puts into consideration both the motor and the sensory neuron, while the Lloyd only puts into consideration sensory neuron.
Thank you. Alamin, capture that. And then the other one, I think I'll ask Nicholas. He had his hand up before.
Elangesa has 3 types of classification, which is ABC. Then Lloyd has 4, which is from Roman numeral 1 to 4.
Exactly. So which type is missing? Who can remember the type that is missing? Found in Alanga-Geisa, missing in Lloyd's. Who can remember? The fiber type found in Lloyd's, but it won't be found in Nicholas. Let's give somebody else a chance. Samuel.
Type B.
The type B. So the type B is missing because of what? Who remembers? Why is it missing?
I think because it's a motor nerve
It's a
fiber.
motor neuron. Preganglionic. Always remember, preganglionic is type B. So I think I'll give you a break. Just maybe 5 minutes or 10 minutes. Let me give you a 10-minute break so that when we come back, I will give you another topic, which is the nerve damage and repair. So I'll have finished with classification. I will start on another topic, which is nerve damage and repair. Let's meet. Right now it is 9:23 according to my clock. Let's 9:13, so we meet at 9:23. Give yourself exactly 10 minutes, and then I'll start teaching at exactly 9:23. You can take a break now.
Hello, Prof.